a quick follow-up video for you. There's a very bright LED. It is difficult to dim LEDs just by slapping resistors in the circuit, but what we can do is just pick up a couple of crocodile clips. What is he doing? Well, all I'm going to do is turn the wheels over upside down, and we're going to run the black one to there, and then so that's going to one of the wheels, the yellow one to the other one, and in between the two I'm just going to put, let's move that somewhere safer, put a variable resistor. Now there are two yellow cables. All I'm going is going on the center connection with one, and I'm going on the outside with the other. And we will then turn the resistor until we get the brightness we want, instead of a beacon on the back. That's where it was. Oh my word, that's actually, I'm intrigued. That I didn't expect. I've got 11,000 ohms in series now, and that I'll explain what's going on there in a minute. Let's change it out for something 5 times that, shall we? All right. There we go. And I'll pop this one away. This is interesting, people. I'll tell you why in a minute. So that's where we were. And even with that, well, that's about the right brightness, to be honest. That's 51,000 ohm. Well, that's not. It's what's going on is that I've added a resistor in the input. It's not quite as clear as you would expect. Yeah, well, we'll just do that. Now, two things going on there. First of all, there is a resistor in series with the diode. And I don't like calculating the diode's brightness by using the current factor. That, if you're not following, you're fine. There's a thing called Ohm's law. Everybody has an idea of what it should be doing, but current is just one aspect. When you see volts written next to a diode, that's how many volts that thing is going to drop come what may. And it may take an incredible amount of current to do that, or it may take 20 milliamps, which is what they're rated at. So you kind of want to use the volt part. That's one aspect. The other thing going on here is that typically you cannot dim sensibly LEDs by just adding resistors. You've seen me do it with pulse width modulation. The reason is that the tail off happens, I'll draw it for you, but it happens really quite suddenly. All right, just a quick one for you. This is brightness, so down here it's dark, and up here is a nuclear sun, and along this way is resistance. With an incandescent bulb, let me put ohms there. With an incandescent bulb, it's not quite like that, but it's more like that, a straightish line. With LEDs, if we've got, let's say, 1 megohms there, it's going to be dark. There's going to be no current flow, none whatsoever, until you get to a magic point, and then it's going to do that. And then it's going to do that. And then it's going to do that. So there's a funny little curve that these things have. So as you lower the resistance, nothing happens. So this might be 500 kilo ohms, and this might be around about 10, and I'm adding numbers here based on, let's say, 12 volts. All of a sudden, bloop, it pops on, and when it comes on, it goes whack and it's on. And it stays on full brightness until you lower the resistance more, and it suddenly takes off, and then up here it goes into a real nuclear cloud because it blows up. Poof. When you're trying to control the brightness of LEDs with resistors, you're working in just this little bit here. So that isn't a straight up and down line. So there's a very, very shallow part, that bit in there, where you've got any control over the brightness at all. All of the lights, all of the street lights around the layout are calculated to have a 1K resistor. Now I put 1K in each leg, so it's 2K. But it makes absolutely no difference to the brightness as far as you can tell. But what I've done today is we've got 100K and we've forced it into this little zone here. So that's one aspect. The other aspect is that we've got two things going on. First of all, we've got a safety resistor in series with the diode. Absolutely, so that it cannot get bigger than 20 milliamps. Not possible because of that resistor. But what we're also, so that's going to be at full brightness. We've also got a bridge rectifier kicking out in there. Do you remember that? We're rectifying, what we're actually rectifying is the DCC. And what we're going to get out of there, something in the order of 15 volts. Now, I could measure it. I had a meter out, but it's going to be something in that range. So you can calculate it, or you can do what I just did. You can suck it and see. So what I'm going to do is just add a resistor in series with one of the pickups underneath the wagon. It'll only take me a minute. What value was it? I don't know. The advantage of this too, if you think about it carefully, if you just whack in the resistor that would work, you've got 3 volts being dropped, or whatever it is, 2 volts or something being dropped across the LED, and then you've got a 1K resistor in series with that. Well, the other 15 volts, put it bluntly, if you added this circuit to a dozen wagons around the layout, the resistance across the rails would get very low very fast. We don't want that. It would show up as a short circuit, wouldn't it? So trying to get the resistance as high as possible has another advantage. Not only does it dim the LED down, I'm still going to paint over it, or can we force it into that little zone where you can actually control LEDs with resistors. There you go. Here's a tip for you. Box of resistors, all kinds of values. Now, they were all in there once. They all fit nicely. And now I can't get the... Well, that does close. Isn't that good? Yeah, but only about a third of them are in there. The rest are all over the toolbox, needing to be put into those storage kits. Now, once you've used the variable resistor, what you do is you get one of the resistors that you think the value is and hook it in. And look at that. Can you see the dim tail light just about working there now? And it goes off a little slowly because of the capacitor inside. Love it. So that's the right value, and all I'm going to do is solder that onto the bottom of the van. I'll take it onto the bench so you can see what I'm up to there. All right, so let's see if the soldering iron is hot enough. Probably is, yep. Just going to disconnect one of the wires, doesn't matter which one. There we go, off it comes. We've got our resistor here. Now this one happens to be 100K kilo ohms. I'm not taking that guards van all to pieces again to put it inside. We'll just pop it on the bottom. Nobody will ever see it. And shorten the wires right up. There we go. And the first thing is move the wire out of the way. I'm just going to use tweezers just to hold on to it. I'm more used to using pliers, but in this instance, tweezers it is. So I'm trying to keep my big mitts out of the way. Just start flickering if I don't hurry up. There we go, there's one. And then the other end, the wire just goes back onto there. I'm just going to put a little solder on that. Just cleaning the tip up a bit. Bit of live solder there. Let me just tap that on there. It should do it. I'll bend it right up against the floor. There you go. Now the trick is, does it work? Shall we take it upstairs and have a look? Oh, I didn't. I did. I touched that brake rod again and broke it again. Do you see that? I'll put a bit of glue on that when you've gone to bed. I did want to paint the top of that handle red, but we'll do that another day. Well, there we go. That's much more like it. And there will be a little bit of a flicker. The capacitor inside could be bigger, but as it goes along, it won't go out suddenly. It will just dim down a little bit, but that's much more the brightness we want, isn't it? Actually, it looks like it's supposed to be there. So yeah. Now then, that's much more like it, isn't it? I've been at work all day today, and I was thinking about that. I thought I better correct that before I get 300 comments in the comments section down here telling me what I did wrong. The resistor does work. It's just you've got to be very careful in that little window that you have, so that it doesn't go off or stay off, or you double the resistance or quadruple the resistance and nothing would have actually changed. Now, somebody asked already, what was wrong with that locomotive? Why did you ever get to it? Poor thing. It's still not over. The story's never ending, isn't it? I've got some grease on order. It was supposed to have come today, but hasn't. That really is conductive this time. So thanks to whoever it was that recommended that. You know who you are. Thank you. Here's the list, though, of things that were wrong with it. I'm reading off of my clipboard here. I'll show you that. Isn't that clever? The rail for the arches holds my my notes. So the things that were wrong with it: a faulty chip, broken front pickup wires, split axles. There were 3 of them. The grease in there was solid. It was almost like glue, wasn't it? Do you remember that? The conrods were the hole in one of the conrods was elongated and the clip was missing. The valve gear was unglued on both sides. The bearings were worn through, and the nickel coating was falling off on the wheel rims. So nothing much then. One poor thing. The other thing is, well, somebody said, well, you know, they wouldn't like to try it. What would they do? And would you do it commercially? Well, no. I mean, it would. You could do it for the love of doing it, but no, sending it in to somebody, first of all, they would have to get the repair right. And if I got a locomotive back, having been sent in for repair in the state that I've left it, I would go, because it would just cost a fortune. It's taken me hours, not very many hours, but a few hours, and you can't do that. So old locomotives do die, but yeah, let me just cover one more thing, and we'll completely different subject. So we've had the brightness of the LED, what was wrong with the locomotive, and here's another little thought for you, just to get you thinking. A level crossing. This is where the airport ends, and there's the trees need to be moved, and the just to give you some orientation. That's the layout board that I'm going to be doing some work on over the next few days. And of course it sits in that hole. Let's just talk about level crossings for a moment. Train comes along here, something is going to trigger something to make these gates work. And then what if the train comes the other way, or when the train is finished? So there's all kinds of sensors you could have. Let me break it down into the simplest terms I know. Here comes a train. I can see it. The gates are in the right position for the train. Now, train goes off through the crossing. I can see the train has gone. So the input then is my eyes, and the device I'm using to open the gates is my finger. So there's what's happening. Now, do I want them to open like that, or do I want them to open and close two at a time? I don't know, we haven't talked about it yet, but the gates need to be opened and closed. Now, here comes another train. It's coming the other way this time. Gates are in the right position. Let's put the gates closed for the train and open for the road. There we are. Now, here comes a train. Well, train needs to be stopped. Needs to be a signal. So I can put a signal there. Stop, stop. I can see there's a train coming, so I do something about it. And away we go. Now, anybody living in America doesn't know what that's about. That's what I am. Because at some point, we're going to get an Arduino to do some of the things my eyes and hands have been doing. So there's an input device. What does that mean? I can see the train coming, so input. And here's an output device. So my brain is the Arduino, if you like. I see the train coming, and my brain tells my hand, mess with the gates. So what might that look like? Well, there's a sensor. That's a light-dependent resistor. So as the train casts a shadow over it, the resistance of that device changes. So that would be like my eye. That's like a magic eye, if you like. So that's an electronic eye of some sort. All kinds of things we could put there, but that's what that is. There is some sort of cable that goes between it and this. I don't think it's that one. This is the Arduino Uno, and that's like my brain, if you like. So that's my eye, my brain. So what's my hand? This thing then has got to tell one of these things. These are servos. There we are, some gears and things. And so when the Arduino decides my hand, the servo, needs to move, it will tell it how much to move, and it will turn that thing on the end, which will presumably turn one of these things, and I will have to get clever and figure out how to fit one of those things to one of those. And probably I'll end up using either 2 or 4 servos. I was doing it all with one, wasn't I? Well, I suppose I have a servo in each finger. You could say that. Now, the rest of the puzzle, I've tried to explain it as simply as I can see it. The rest of the puzzle is, how do you sense the train is coming in time to get the gates in the right position? How do you know the gates are in the right position? And then how does the brain, the Arduino Uno, that's all it's called. I should call my brain Arduino, shouldn't I? I think my brain's better than one of these things. And then how do you get it to talk to the servo? Now, there are some clever connections we have to make in the process, and we'll go over all of that. And there's some clever code somebody has got to write. Now, Leopard's Tail, another channel. He's in the middle of doing all of that stuff, so I'm going to go and see what he's up to. I'm sure we can figure it out. Now, what's going to happen then? At some point, there will be a train comes along. Those will start off in the road position, shall we? At some point, a train will come along. A signal will change only when these gates are in the right position. and then the train will pass. The signal will revert to red or drop. And we could use there's a thought. We've got a whole box of those things. We could use another one of those to drop down a signal, couldn't we? And then the gates wait for the next train to come along. I am making it sound very simple. I'm trying to break it down into bite-sized chunks. Just like that. Oh, I could never do that. Well, yeah, how do you eat an elephant? It's back to that. One bite at a time. Do I think I could get one of those to make a gate do that? I don't think that's going to be difficult. We've already shown we can detect a train coming along with a light-dependent resistor. Now, how do we connect that to that? And of course, we're going to have to use this. I've never used one of these. I've used them, but I've not used them where I've had to set it up. Another project, radar on the roof. In this area, there is an entrance to the airport, and I want to have a barrier that goes up and down again when you push a button somewhere on the side of the layout. A kid-friendly device, as it were. I have got to fly to Havana, Cuba in the morning. I told you June was a flying month for me, didn't I? And so I won't be able to do this tonight, but that's what I'll be thinking about when I have a little bit of spare time. I might get on the internet and see what getting an Arduino Uno involved in opening level crossing gates will actually mean. I have two of these, and I wonder, do I need one for this and another one to do that? Or could I make the two things operate from the same little magic computer? We've got to learn how to make it work first, haven't we? I think the radar may go around all the time. Well, that's all I've got for you today. 3 or 4 different things, a little bit of a magazine format. I have no idea what to call it now, but we'll see how this works. Thanks for watching and appreciate you all. Hit that like and subscribe if you enjoy these videos. It just gives me a little bit of an encouragement. See you next time now. Bye-bye.